Good afternoon. In today's session, we are supposed to study our second unit, that is nothing but the baseband digital transmission, in which today we will see about the multiplexing hierarchies and the data multiplexer. In previous session, we have seen about the time division multiplexing, digital multiplexing. So here we are saying we are supposed to see about the bandwidth utilization. That is nothing but it is the use of available bandwidth to achieve our specific goal, and we can get efficiency by using the multiplexing, because here we are sharing the bandwidth between multiple users, because by using the multiplexing we are supposed to select one out of multiple signal. So here we are sharing the bandwidth. So you can see here multiplexing, it refers to the combination of information streams from multiple sources for a transmission over a shared single medium. It means what? Here we are supposed to use multiplexing at a transmitter, so we will select one out of multiple, and again we will separate reconstruction of our original signal by using the demultiplexer at the receiver side. So you can say about the demultiplexing like it is the process in which we will do separation of a combination back into our separate information signals. So you can see here the diagram for the multiplexing and demultiplexing we are doing over a single channel. So here what we are saying, when we will do multiplexing at that time, out of n channels we will select one channel according to time slot, because here we are studying about the TDM multiplexing. It means what? Here we will give the time slot to each and every signal, and we will share that signal over a channel, and at the receiver we will again do the separation from that channel, from that signal which we will get over a channel. So here we are sharing the medium, so in which whenever the bandwidth of medium having two devices is greater than bandwidth need of device, the link can be shared, because according to the Nyquist theorem. And multiplexing is nothing but it is the technique which will allow simultaneous transmission of multiple signals across a single link. So here data and telecommunication will use increases, so does traffic. So you can see here about the multiplexing. There are different types of multiplexing like analog and digital. In analog we can see about the frequency and wavelength division multiplexing, which already we have studied. And here we are supposed to see about the digital multiplexing, in which we will see about synchronous and asynchronous time division multiplexing. FDM already we have seen. So here there are two types of digital multiplexer. These are nothing but we have seen TDM. In TDM we have seen synchronous and asynchronous. Synchronous means it means what? All are having the same time slot, and if different signal are having different time slot, we are saying that as a asynchronous time division. So here we can say about the multiplexing hierarchies, in which we will get the two types of digital multiplexer. These are low speed multiplexer and a high speed multiplexer. So low speed multiplexer are nothing but these which can be used with the digital computer system to merge digital signal from several sources, and the output rate of these multiplexer, these are nothing but low speed. These are standardized output rate from 1.2, 2.4 up to 19.2 kilobyte per second. It means what? Here we can designate output as a digital signal DSO 0 for signal level 0. It means here if we will get the output rate that will be in between 1.2 kilobyte per second to 19.2 kilobyte per second. We can say that as a low speed digital multiplexer. And there is another type, that is nothing but high speed. So high speed multiplexer can be used in a commercial data transmission system because two different multiplexing standard which we are supposed to see in our syllabus. In our syllabus we are supposed to see about the baseband digital transmission, in which we will see about the high speed multiplexer which can be used at a commercial data transmission system. So here these multiplexing have been adapted for digital communication. If you see the at and T hierarchy, it will be used in the America and Japan. We can say that hierarchy can be used in the America and Japan. And CCIT hierarchy, the another type that can be used in the Europe and the rest of world. So we will see both of these. So firstly we will see about the at and T hierarchy, which is used at a North America and a Japan. So here you can see the diagram for the at and T. So here what we are saying, here when we are saying about the at and T hierarchy which can be used in the North America and Japan, here we are using that multiplexing for a telephone industry which has standardized bit rate, that is will be high speed. It means what? It will have bit rate 1.544 megabyte per second, 6.312 megabyte per second. So we can assign these as a digital signal 1, digital signal 2, digital signal 3, etc. It means what? Here we are supposed to use higher bit rate, but in low speed we are using bit rate from 1.2 kilobyte to 19.2, but here we are using megabyte 1.544 megabyte. So here higher digital signal level we will get higher data rate. So here different transmission medium can be used for different digital signal. For example, if we are using higher digital signal level, fiber optic cable, microwave link we can use. So here we will see about the at and T hierarchy, which will shown in the diagram figure 6.9. You can say this as a at and T hierarchy, or you can say this as a analog hierarchy, which can be used in the North America and Japan. It shows the transmission of voice data from computer, visual telephone and color TV signal on a single T4 lines. So here now we are talking about the FDM, because here analog, but when you will see about the TDM, which will be digital, what we can do here, you can write here TDM instead of FDM. TDM PCM you can write here. It is nothing but time division multiplexing pulse code modulations. Here what we are saying, here we are supposed to use time division multiplexing. So here if we are using the time division multiplexing, at that time we will give them time to all signals. Here जैसे यहाँ पे group नाम दिया है and we are giving here frequency. Instead that what we can do, here we can give the time slot. So if you are saying about the first group, after the telephone, after the TDM, if you are saying about the first group, first time slot, so you can say T1 carrier PCM voice or multiplex data will have data at a speed 1.544 megabyte per second. You can say here it will have the speed that will be 1.544 megabyte per second. For such T1 lines, we can say, or a digital signal 1. These are multiplexed by multiplexer, the second one. We can take first one as a M1, second you can take as a M2. So you can take that will add bits per frame synchronization, and hence we will get the additional number of bits per frame. So here you will get the speed that will be 6.312 megabytes. After that, when you will sending this to the third one, M3 multiplexer, it will again add bits for the synchronization, and hence you will get additional bits per frame. So here you can say this multiplexer, the last one, the fourth multiplexer, will again add the bits for synchronization, and hence you will get the additional number of bits per second. So at last you will get here 274.176 megabyte per second. That's why we are saying this digital multiplexing as a high speed, because here we are having the speed from 1.544 megabyte per second to 274.176 megabyte per second. We will see CCIT in the next class. Thank you.